started. Good afternoon, everybody. Welcome to Monday afternoon at Chem 170 Organic Chemistry with your host, me, Dr. White. I hope you all had a nice spring break. Last week I was teaching at the other school I teach at, and this week they're off. So it happens once in a while when they're not two schools in phase. Well, that's life. Anyways, hopefully you all had a good spring break. A couple important things. Don't forget, remember to keep on turning in your labs. Also, I can't remember, I think I might have said today, but I can't remember. But let's do it Wednesday. This way, in case you didn't do it, you have time to do it. Let's go through the carboxylic acids and esters problem set this Wednesday, and we'll do it then. And that way you'll get the practice, we'll get the practice, so you'll do good on test number 3. Wow, we're already at test number 3 coming up in a week or two. Wow, time flies when you're having fun with organic chemistry. All right, oh, by the way, I forgot to ask. Over break, did you happen to pick up a bottle of vinegar and think that it has acetic acid in it, which is a carboxylic acid? Or did you pick up a bottle of maybe ketchup and you think, wow, that's got vinegar, which also has acetic acid in it? Or did you pick up a bottle of nail polish remover, which had ethyl acetate, which is an ester? Did you do that? It won't hurt. Or probably this one you probably didn't do. Did you pick up a can of pop, look at the ingredients label, and say, ooh, it's got sodium benzoate, which is a carboxylate anion? Remember, organic chemistry is all around you. I stole that from SpongeBob, and it won't hurt for you to think about it when you're not in my class. All right. Now, when we left off, well, about a week ago Wednesday, or the Wednesday before spring break, I was talking about amines and quaternary ammonium salts. And let me remind you, if it looks like I'm having way too much fun, I am, because this is an area I've worked for many years and still do. And I have about 9 US patents in this area. Do I know it? You better believe it. All right. Now, I showed you, and let's do a quick review. That's not what I want. That's what I want. A little rusty on my tablet here. And amines have this form. Remember, nitrogen normally has 3 bonds, and here our prime and our double prime can be hydrogens. So you could have a primary amine, secondary amine, tertiary amine, which I'll never ask you about. Then I also talked about, and we went through the common nomenclature, which you should know. Oops. Don't need the minus sign down there because it's already up here. And for this class, the anion quaternary ammonium salt has 4 groups. And here our prime and our double prime and our triple prime are never hydrogens, because otherwise there wouldn't be a quaternary ammonium salt. And I mentioned last time we met One of the big uses of quaternary ammonium salts is fabric softeners. And that's an area I worked very strongly in. And just to, I think I might have shared this with you, but I better share it now. If you're using a fabric softener, and I've worked for a company that sold half the molecules that were used for fabric softeners in the world, and we had our competitor. But anyways, having done that, I worked a lot with Procter and Gamble and Unilever people, and I learned that, you know, the fabric sheets, the dryer sheets, that's the best way to get fabric softener on your clothing, and makes it nice and soft, and also anti-static too. But we're almost over to winter. Hope, hope. Did I tell you back when I was a junior in college, on the 14th of April, we had a monster snowstorm here in Chicago. It dumped about 14, 15 inches of snow, and the next day it melted. That's the only time in my life I can remember that the IRS postponed for the Chicagoland area the April 15th deadline by one day because it was such a mess here. It was. All right. One other thing I thought I was thinking about this morning, I didn't talk about, is in our present situation with COVID-19, you go into stores, and even before, if you went to stores, and you can buy them for yourself too. You know those wipes that are antimicrobial? Well, guess what makes them antimicrobial? A quaternary ammonium salt. One of the other main uses of quaternary ammonium salts is antimicrobial. Ooh, that reminds me, hold on, hang in there. I'll be right back. I almost forgot something important. I'm back. If we had been at ECC, I'd have to walk all the way back to my office to get what I forgot. And guess what time it is? It's show and tell time, Dr. White show and tell. And first of all, I'll tell you, then I'll show you to you. I guess it's tell and show as opposed to show and tell, but it's both. Unfortunately, in my family, one of the things that's hereditary, and it didn't skip me, is dental problems. Anyways, and one of the problems I've had earlier in my life was problem with my gums. And they get inflamed, and then I go like this, and they would hurt. Well, I had a great dentist. He was a doctor too. He had a PhD in dentistry. But anyways, great dentist. And he had prescribed this prescription mouthwash. And it was about 600, 700 milliliter bottle, this diameter. And it was prescription, and it cost about $60 a bottle. And that was expensive. And plus, it made your teeth somewhat brown. Yeah, but it kept your gums nice and healthy. Well, anyways, unfortunately, he had to retire because of health reasons. And I had another dentist I didn't like. So I was in between dentists. I was running out of that mouthwash, and my gums were starting to hurt. And I said, wait a second. Must have an antimicrobial. And I'll find a mouthwash that I can buy over the counter. It should work. Well, there are two types, Listerine and Scope. This is not Scope though, but Scope type. So I went to my local big box store and I bought some Listerine, or a Listerine knockoff. It was Walmart. I only go there about 4 or 5 times a year, but it's worthwhile, some of the stuff they sell. And I tried it and it didn't help. I said, oh, so I went back and I looked, they had a whole wall of mouthwash. There are just two types, the Listerine and the Scope. So I picked up the bottle of Listerine, looked at it, being an organic chemist, and it had a phenolic compound. Phenols and derivatives of phenols have antimicrobial properties. Well, it sure didn't work in mine. And then I picked up this and I looked at this and it said it has, near the end, it has cetylpyridinium chloride, which is a marketing way of saying a quaternary ammonium salt. And this quaternary ammonium salt, I figured I'd try that. Well, instead of buying Scope, I got the obviously Walmart brand, which was half the price or more. And I used it, and lo and behold, ever since I've never had gum problems. So quaternary ammonium salts play an important role in our life, and one of them is an antimicrobial. And if you need a good mouthwash, and I don't get any kickbacks from them, that's the benefit of knowing organic chemistry, because you can look at the labels and understand, well, is this better than what's different from this and that? And you can pick out the key ingredients and figure it out. So this is a quaternary ammonium salt. And I'm going to be real good and not use slang. If you work in the industry, we call them quats. So I said I wouldn't do that. Oops, it slipped out. But anyways, that's quaternary ammonium salts. All right, let's get back to work. Now, switch is totally off on this slide. Click. They're physical properties of amines. And amines, the smaller ones, have a very strong ammonia odor. If you've ever smelled ammonia cleaner, it can knock you off your feet. Or better yet, which you probably haven't, but I have, if you ever worked with liquid ammonia under pressure and some of it escapes, it's pretty strong. One of my less favorite memories is supervising. I was at a plant and I was helping out because they were short a manager. And in the summer, I was in one of those hazmat suits with the tank on your back and the mask over your face. So it was 90 and the humidity was 90. And I had to supervise unloading a tank car of ammonia. Not fun. But anyways, and most amines, except for the very smallest ones, where R is like 1 carbon or 2, things like that, are liquids and solids at room temperature because they can hydrogen bond or form ionic bonds. Now, how do you make amines? And I apologize, it's an overcrowded slide, but let's go through one step at a time. Here's ammonia. And if you react it with an alkyl halide, where X can be chlorine, bromine, or iodine, what happens is the lone pair of electrons on nitrogen is looking for a positive charge. And that slight positive charge on the carbon to halogen is, and it comes and attacks that. Yes, we actually use the word attack. Organic chemists are very violent. And you lose this and you lose the hydrogen. And what you get is a primary amine. Remember, nitrogen can have 3 or 4 bonds, and amines it only has 3, and you get HX. Now, since that's inorganic, you don't have to worry about that. I don't. And that's how you make primary amines. Hold on, let me click this off. So let's take an example. And it doesn't matter which you put first. Oh, one other thing to neutralize this, you usually have a base present. Always do, actually. And something like sodium carbonate will do the trick. But I'm not going to ask you to memorize bases, so I'll just use base. And here, what do we have? What's different? Look for what's not carbon, what's not high. Ooh, chlorine on this carbon, it's an alkyl halide. And here, ooh, ammonia, that's different. And the presence of base. you get a primary amine. And what's our this? What carbon has the halogen? This one. Do you break carbon-carbon single bonds? No. Anybody have dreams about me saying that? I hope not. And the carbon with the halogen now will have NH2. And you've made an amine, a primary amine. I'll never ask on tests what's a primary, secondary, tertiary amine. And it's your turn. What would be the product or products of the following organic product or products of the following reaction? 3 points each. While you're doing that, I'm going to put away my mouthwash because I don't need it. I used it already today. And it looks like everybody's done. So we look at this molecule. What's different? What's not carbon or hydrogen? Ooh, halogen on a carbon, alkyl halide. X can be, again, oh, I'm in my chlorine, bromine, or iodine. And we're reacting it with ammonia in the presence of base. And what you get is a primary amine. Remember, there are 3 bonds to nitrogen and amines. What's my R group? This. Do you break carbon-carbon single bonds? No. So I have 4 carbons. And which carbon has the halogen? This one. And it will be bonded to NH2, the nitrogen. You lose 1 hydrogen here, 3 bonds to nitrogen. The NH2 counts as a bond to carbon. Carbon still has 4. And there you go. Now, on test number 3, like test number 2, I'll have 3 or 4 synthesis problems. And the question would be, what would you react with ammonia, NH3, to make this compound? And this is the fun part of organic chemistry, at least for me. I hope for you too. And a public service announcement, don't forget tonight and Wednesday from 5 to 6:15, I'll have my office hours. Now, if any of you think a better time for office hours, I can always change them. It's not written in stone. I was thinking, would Tuesday work and Thursday work better for anybody? Let me know by email if that's a better time. Maybe from 6 to 7:15. All right, I better get to work. Now, if we look at this molecule right here that we're trying to make, what's different? Ooh, what's not carbon? What's not hydrogen? This nitrogen. It's a primary amine. What's our R group? This. And what are we reacting to make that primary amine? Ammonia. And what do you react in alkyl halide? Where X can be chlorine, bromine, or iodine. Since I didn't specify anything over here, you can use any one of those three. So what's my R group? A cyclopentane ring with a methyl group. Think about that. 6 months ago, if I had said cyclopentane ring with a methyl group, would you even know what I was talking about? Aren't you proud of how much you've learned in the short time we've been together? I'm proud of you. All right, now, the carbon with the NH2 group is the carbon with the halogen, this carbon, which is this carbon. Since I already used chlorine, I'll try, how about iodine? You could have put Cl or Br there too, and that's how you do it. Now, that's how you make primary amines, one way. Now, let's go back. The next thing I like to talk about is this right here. If you take a primary amine and react it with an alkyl halide, now in the presence of base, you'll form a secondary amine. And let me write it again. And all these reactions I've done in the lab, and some of them I've also done in plants too. And now, again, the non-bonding pair of electrons and nitrogen are always looking for a positive charge, and they attack the carbon with the halogen. You lose X minus and H plus, HX, which is neutralized in acid by the base to give you salt and water. It doesn't matter which side you put R and which side you have R prime. One side has R, the other has R prime, and you also have a hydrogen because in the amines there's 3 bonds to nitrogen. So oops. And here, if we look at this reaction, the question is, what are the product or products? Remember, these are the tools that organic chemists like me use to make new molecules, which you use in your daily life. And here, what's different? Ooh, a nitrogen. What's not carbon? What's not hydrogen? On carbons, it's a primary amine. And here's my R group. Over here, ooh, carbon with a halogen. This is an alkyl halide. and I forgot to put here, sorry, I do that a lot of times. In the presence of base, what do you get? A secondary amine, and this is my R prime. So I have my R group, nitrogen, and then what's R prime? Methyl. And we have that secondary amine. So a primary amine plus an alkyl halide, and remember X can be chlorine, bromine, or iodine, gives you a secondary amine. And here's one for you to have fun with. What would be the organic product or products for the following reaction? You haven't realized that we're doing some very sophisticated organic chemistry, and hopefully it's not painful. All right, I think everybody's done. Let's take a look at this. Remember, the key to organic chemistry when you're doing reactions like this or trying to understand things is look for what's different. It's not a carbon-carbon single bond or carbon or hydrogen should get your attention like that. Got mine. And if we look at the first molecule, what's different? Carbon, ooh, nitrogen on carbons. This is a primary amine. The second one, carbon, carbon, carbon. Ooh, halogen on a carbon. This is an alkyl halide. And in the presence of base, you get a secondary amine, at least organic. So what's our this? What's our prime? This. Remember, this is a carbon with the halogen, which is the carbon that's now at nitrogen is bond to an R prime. Now, do you break carbon-carbon single bonds? No. So I'm going to do this way because it's easier to draw. And here's the carbon that had the halogen. It will now be bonded to nitrogen. What's my R group? Ethyl. And don't forget, there are 3 bonds to nitrogen in amines. And therefore, if you only have 2, the third one is going to be hydrogen, just like similar to what you did with carbon all this semester. All right. Wow, that's a pretty looking amine. Now you know he's an organic chemist. All right. Now, let's try a synthesis. And what two molecules would you react together to make that product? Ooh, I'd make this one maybe even 6 points or 4 points, 2 points each, or maybe 3. All right, I think everybody's done. So let's look at this. How do you do it? Well, you look at the product, in this case, and what's different. Ooh, a nitrogen. Remember, what's not carbon, what's not hydrogen should get your attention. Like, ooh, I haven't used this in a long time. Like that. And we have a secondary amine. And how do you make a secondary amine? You take a primary amine plus an alkyl halide and react them together. And X can be chlorine, bromine, or iodine. Since I didn't show you what acid you'd get or salt, you don't know, so it can be either one. So now let's call this R and call this R prime. In that case, this would be your amine, and let's pick a hal. Oh, I haven't used bromine. You could have put here iodine or chlorine too. Now, this is one of those cases in organic chemistry when there's more than one answer. What if I call the methyl group R prime and the ethyl group R? Well, in that case, that would be my primary amine and my alkyl halide. And let's stick with bromine. You could have also put chlorine or iodine, would be that. So which is correct? The top one or the bottom one? The answer is, for this class, both are. Now, if you know your cost accounting, I would assume that the blue one may be a little less expensive when we're talking about what the direct cost of the chemicals are. But not that much difference in this case. So that's how you make a secondary amine. Now, a secondary amine still has non-bonding pairs of electrons right there. And you can react a secondary amine with an alkyl halide in the presence of a base to make a tertiary amine. And let's take a look at this reaction. And here, again, the non-bonding pair of electrons are looking for a carbon that's slightly positive. That's called nucleophilic attack. And it attacks the carbon with the halogen bonds to it, kicks out, loses an H, loses an X. That's why you have the base present. And you now form a tertiary amine. And it doesn't matter which side has R prime, or R double prime. So let's take a look at this one. Now, let me remind you, unlike carbon, you can use parentheses like this. Notice it's a methyl group in a parenthesis, and to the right, subscript is a 2. On a test, I'll write it this way, but you can think of it as this molecule. Both are the same way, but this one's easier to write with the software, and organic chemists are lazy. I am. Anyways, what do we have here? A secondary amine. In this case, R and R prime are methyl. What do we have here? Ooh, a methyl group with a halogen. And we have an alkyl halide. Remember, X can be chlorine, bromine, or iodine. And the presence of base, this attacks that, kicks out HX, which is neutralized by the base. And you get a tertiary amine. And this tree with a superscript 0, like a degree sign, is how we do tertiary. 2 superscript little 0 or degree is secondary, and primary is 1. But anyways, here, what's our double prime? Methyl. So I could have write this like this. There are actually different ways. That's one way. That's another way, which I would never do, but you can. And the other way, which I probably would never do because I'm lazy organic chemist, but it's totally correct on test, is this. And you could have one of the methyls on top. So it's 3 sides. Each side has a methyl group. And that's trimethylamine. Ooh, let's have some fun with this one. And here's one for you to have fun with. What would be the organic product or products are the following? I don't know about you, but the other school, a lot of students, because it's optional now, are not wearing masks. I'd say about 80%, but I'd still play it safe because you follow what's happening in China right now, they're getting another wave. And part of that also could be because of the vaccine they use, not the type we use in the United States. that's based on, what is it, RNA. They have something else which is not as effective, and it's proving not as effective. So even so, got my both shots plus my booster, but I'm still wearing my mask. All right, I better get to work. And if we look at this first molecule, what's different? What's not carbon? What's not hydrogen? Ooh, and nitrogen. There's a methyl group and a cyclohexane ring on there. This is a secondary amine. And what do we have here? Carbon with a halogen, an alkyl halide. And X, remember, can be, in this case, it is chlorine, bromine, or iodine. And when you react it, the lone pair go like this, kick out X, and you also lose the H. And you get a tertiary amine. And here we can call, say this, doesn't matter which you designate R and R prime. And then the methyl group is R double prime. So I have my nitrogen, what's attached to it, a cyclohexane ring, and a methyl group. And then my R triple double prime is a methyl group. And I have my tertiary amine. You could have also written it this way. Because notice there's two methyl groups. Oh, hold on, that looks awful. And that would be that. Now, a while ago, and we haven't seen each other for a while, so I should remind you that when you're doing stuff in my class, you should be able to ask the question, why am I learning this? Well, the obvious answer is somebody said you have to take organic chemistry and you want to get a good grade so you can get into a program or a school. But why learn this? Well, these are building blocks. And look at the molecule you just made right here. It's got a nitrogen with two methyls and a cyclohexane ring. Now, this is a commercial product that has a commercial name called Polycat 8. And it's been around for decades. I've actually used it. If you go back and look at some of my patents, I use Polycat 8. Why is it called Polycat 8? Well, if you notice 6 carbons on the ring and 2 methyl groups is 8. And it's a polymerization catalyst, Polycat, to make urethane foam, like the insulation inside your refrigerator in the walls. And I'll talk more about it when we get into polymers, but this is an important catalyst to this day. It's still being used. I think Air Products sells it. Used to be somebody else and Air Products bought them. But anyways, this has been around forever, not about ever, but at least since the 1980s. Wow, I don't even want to add how long it's been up. But anyways, that's what we use these reactions for. And here's one more for you to do. What would be the 2 products I react in the presence of base to make that molecule? I should point out certain amines are used. Well, I'll talk about it later. I'm getting ahead of myself. Bad, Dr. White. It's one bad thing about Zoom, and a lot of you don't have your cameras on, that if I were face to face, I could just look around the class and I would know when everybody's done. But that's why I use this poll. And when we're in face to face, I'd say look up and smile. And I see all those smiley faces sometimes. All right, let's take a look at this. What's different in the product? Ooh, a nitrogen with not one, not two, but three R groups on there. It's a tertiary amine. Now, it just so happens R prime, and R double prime are all methyls. And how do we make a tertiary amine? In the presence of base, you take a secondary amine and react it with an alkyl halide. And in this case, what's R and R prime? Methyl. So I can write it this way, dimethylamine. What's R double prime? Methyl. And here, you could pick any of the three halogens, which could be chlorine, bromine, or iodine for this product. And I haven't used bromine in a while, so I better use it. And this, in the presence of base, will give you that. And again, the key point is the non-bonding pair of electrons on nitrogen will attack this right here. Well, if you look at a tertiary amine, you still have non-bonding electrons. So you know what that means? And note, like I've been saying, nucleophilic attack of the nitrogen lone pair electrons on the carbon that has the halogen, the alkyl halide. But now, a tertiary amine can react with an alkyl halide in the presence of base to form a quaternary ammonium salt. And let me rewrite this. Oh, wait a second. You're just going to have to wait 5 minutes because it's time for our break. So let's take a break. I'll see you in 5 minutes. I can get up and Sorry about the phone call. I know who it is. I'll call them back after class. They can leave a message. All right. Let's get going. All right. Right before our break, I was talking about the next reaction, and that's if you take a tertiary amine and react it with an alkyl halide, you get a quaternary ammonium salt. And this is a very special reaction for me. Why? Well, it helped pay my mortgage, a couple of cars, got me around the world. Yep, this is a very special reaction. And let's take a look at this again. You take a tertiary amine and react it with an alkyl halide, where X again can be chlorine, bromine, or iodine. Again, the lone pair, but now something different happens. In this reaction, nitrogen provides both electrons because you notice it doesn't have a hydrogen to lose. And therefore, since it does that, it will have a positive charge. And because all molecules in nature, is all molecules everywhere, which I guess all molecules in nature, have a zero net charge, you need an anion here. And for this class, I'll use halogens. There are other anions that I've used, but for this class, I'll just stick to the halogens because there are other ways of doing this with other reactions with tertiary amines, which I won't do this semester in this class. You do not have to show the charges here. If you don't want to, that's okay. I always will, because I think it looks cool, and it does. Now, another fallacy students think is, I thought you said nitrogen has either 3 or 4 bonds. I'm talking covalent bonds. The bond between this nitrogen and this halogen anion is an ionic bond. We generally write it to the right of the cationic part. Cationic, the one has the positive charge. And that's just how organic chemists do that. But this halogen is not bonded to this R group, it's bonded to the nitrogen in an ionic bond. Let's have some fun. And here we go. Let's do this. What do we have that's different in this first thing? Now we're getting the good stuff because we're reacting 2 organic molecules together. We have a nitrogen with carbons on it. And notice there are 3 of them. So this is a tertiary amine. And here are our prime and our double prime are methyls. Here we have carbon, a halogen on a carbon, and alkyl halide. And the presence of base, and let me not forget, X can be chlorine, bromine, or iodine. And Again, the lone pair attack that and now forms a quaternary ammonium salt. And that's how you do it. So the carbon with the halogen will be the carbon that, in this case, R triple prime, is bond to nitrogen. So it's already on the nitrogen, the 3 methyl groups will still be there. And then what's my R triple prime? R double prime? No, triple prime, I was correct. Uh-oh, he's getting over primed. Oh, that was awful, I'm sorry. And you have 3 carbons. Which carbon has the halogen, the end one? I'm going to show a charge you don't. What's the anion? It would be chloride. And that's how you make quaternary ammonium salts. Ooh, another important area of quaternary ammonium salts and other nitrogen compounds are used are in personal care items such as conditioners and shampoos. And those use also quaternary ammonium salts. But the biggest ones are fabric softener and antimicrobial. All right, let's have you have some fun. I'll write it this way. I could have written it another way. And there's one for you to have fun with. And the other way I could have written it, I wasn't sure what I'd put as the third R group, but I could have also written this one like this. But I didn't. Either way works. And now we're having fun. At least I am. I hope you are. By the way, I've been secretly brainwashing you to have you learn organic chemistry, and it's working. Hold on. Nope, I didn't answer. It wasn't the governor of the state of Illinois or president of the United States. Not that they know who I am, so I didn't answer that. All right, let's get to work. And the first thing you do is look for what's different, what's not carbon, what's not hydrogen. Ooh, nitrogen. That's another way of saying, look where the functional group is. And in my experience, functional group is what's not carbon, what's not hydrogen, what's not a carbon-carbon single bond. I'll even bet on that. You know, I know I'll win because I don't say I'll bet. So we have a tertiary amine. And it doesn't matter which one you call R prime, and our double prime, they stay stuck to the nitrogen, stuck, bonded to it. That sounds, and here we have carbon, ooh, halogen on a carbon. This is an alkyl halide. And in the presence of base, you make a quaternary ammonium salt, something very near and dear to my heart. And remember, X here can be chlorine, bromine, or iodine. And the carbon with the halogen is the carbon the nitrogen is bonded to in the quaternary ammonium salt. So this is our R triple prime. So what's on there are our prime, our double prime is still there. And then notice it's an isopropyl group. Center carbon has the halogen. So the center carbon will be the one bond to nitrogen. And what's my anion? This. And I'll put this here. You don't have to show charges, but I will. And that's how you do it. Oh, I've got to do another one. I'm having a good time. Now, this reaction is very, very sacred to Dr. White. And R sub T means tallow. When we get into fats and oils in a couple of weeks, I'll teach you the actual structure. But it's an R group with 16 to 18 carbons with and without a double bond. All those. And there are two of them on that nitrogen. That's called a tallow group, or sometimes called tallow alkyl. And it comes from, you'll just have to wait where it comes from. And it's your turn. What would be the organic product or products for the following reaction? Let me do this again. Let's try it again. Thank you, everybody. Now, what do we have that's different? Tertiary amine, methyl ditallomethylamine. And here's a tertiary amine. And what do we have here? Ooh, carbon with a halogen and alkyl halide. That's called methyl chloride. And say hello to my old friends here, methyl chloride and ditallomethylamine. And the presence of base, you make a quaternary ammonium. So, I almost, oops, the slang slipped out, sorry. And you have chlorine, X can be chlorine, the halogen, bromine, or iodine. And you make a quaternary ammonium salt. And I can call this R and R prime, the methyl group R double prime, and this methyl group R triple prime. So one way of writing it would be this. Notice I have one methyl group, I'm going to add another. I already have two tallow. And let's go down here because I'm running out of space. Another way of writing it, which would be perfectly correct, would be this way. And I guess another way you could have written it, which would also be correct, would be this way. And that's ditallow dimethyl ammonium chloride. And for many decades, that was the only molecule used as a fabric softener. Do I have time? Oh, I do. Now, this reaction, I was, and I still am, an expert in, world authority on how to make quaternary ammonium salts. And time for a Dr. White story. I was working at Axochem, a large multinational international chemical company. I was charged of all research and development for nitrogen derivatives, including quaternary ammonium salts for all of North America. And one day I get a call from the vice president of marketing and sales, and he's frantic. I said, "What's wrong?" And he said, "I just got a call from our salesman at Procter & Gamble, who was one of our largest customers, period. They used our product for fabric softener." I said, "What's wrong?" "Well, they just reformulated Downy." "How did they do that?" "What did they do?" "Well, they're using a slightly different perfume. And now when they make Downy with our product, the salesman told us it makes their Downy stink." "What?" "Yeah, well, we got to get that solved before otherwise we're going to lose a customer. Big one." We're talking at that time, this is back in the mid 1980s, it was a while ago. We're talking like about $60–70 million in sales and a lot of profit. So I went to work and I couldn't figure it out. And by the way, because it was so important, over a 6-week period until I solved it, which was not a fun part of my life, not at all. It was hell on earth. When I got to work in the morning, I got a call from the president of the company. Right before lunch, I got a call from him. Right before I left at the end of the day, he'd call. This went on for a couple of weeks. "Did you solve it yet?" He was getting upset with me. I said, "This is tough." After a couple of weeks, I realized I was just spinning my wheels. And the people working for me, we had set up odor testing panels, and we just couldn't figure it out. And I finally called the VP of marketing and sales, said, "There's something going on, and I don't think I have enough information to solve the problem. I need to talk to someone at Procter & Gamble directly." And I'd gone there, and my counterpart in their research I knew quite well, Dr. Wall, and so we called, and finally, with enough pressure, and they liked having two suppliers, because when you're in a chemical company or any kind of company, you never just want one supplier, because then they can dictate price, or if they have a problem, you can't make your product. We're seeing that with supply chain issues right now in the world. But anyways, I finally was able to get a meeting set up with the senior perfumer, one of them, at Procter & Gamble. And at that time, there were only 5 senior perfumers at Procter & Gamble. Each one had a certain part of the business. And their job was very difficult, and they got paid really well, I found out, that what the product they made yesterday will smell like the product they make today and will smell that same way tomorrow. And at that point, and even today, they relied just on their nose. Well, before the meeting, about a week before, I actually got a call from a senior vice president of Procter & Gamble. And he had told me, we're going to have this meeting with the senior perfumer. Be nice to him. If you get him upset, we're going to cancel our business with you. Be nice. Also, if you smoke, and unfortunately at the time I did, you can't smoke 24 hours before you meet this gentleman, because even if you're not smoking right then and there, there's still enough might be in your hair, your beard, whatever, to throw off his nose. We don't want that to happen. And I talked to the senior vice president. I said, can my counterpart, he'll be at the meeting, Dr. Wall. He said, no, he's not allowed to meet this guy. I mean, they kept these people protected in their own little bubble that even people in their company weren't allowed to interact with them. I said, but he really needs to be there. So I finally convinced this senior VP to let my counterpart at his company be in that meeting. I brought along our salesman for the region. He picked me up at the airport. And there were 2 of us and about 5 other people. And it was really a meeting between me and the perfumer. And I told them, we've been trying to solve this problem with your new formulation. I was told our quaternary ammonium salt, dimethyl ammonium chloride, makes your product stink, the new formulation. He said, no, that's wrong. I said, oh, really? What's the problem? He said, and I still remember this, I can close my eyes and picture myself in that meeting. He said, the intensity of the perfume, the new one we're using, is less with your product than one with your competitors. Doesn't make it stink, it's just not as strong. And we can't have that happen. And when we formulated it, we used your competitor's product. And I was wondering, why didn't you use ours? I wouldn't be having this headache. They would. Anyways, now that I knew really what the problem was, I went back, and at that time, there was a really great analytical chemist in our analytical chemistry group that I worked with, and I still remember him, great guy, Dr. Chunan Wang. And he and I, we did some analysis, and were able to find out there was this minor impurity that covered up some of the smell of the perfume. When I say minor, it was in there only about 150 parts per million. And I went back knowing that reaction, and once I knew the structure of the impurity, knew how to reduce it, I reduced it to 0. And I got back, because at this point, they now let me talk to the senior perfumer on the phone. And he said, all right, we just tested your newer, the quaternary ammonium salt that you changed how you make it, and it's not any good. What's wrong? Well, now the strength of the perfume is stronger, much stronger than we want. And I found out by adjusting that impurity to about, I think it was 50 ppm, we were right there. And the president of the company thanked me. He stopped calling me. That was a relief, trust me. Well, by the way, I still remember also at that meeting, this perfumer, who the people even in his company were very careful around him, being very polite, made a, which wasn't a joke, but you would think it was a joke. He said, you know, yesterday I smelled something so strong, it blew out my nose. I should have gone home because I couldn't do anything. I was thinking, this guy, Downey, and all their home cleaning products from Procter & Gamble, it was his nose alone that made sure it always smelled the same way. It's one of the things I learned from working with Procter & Gamble, also Unilever too, that they had the most profound respect for the housewife, American, also international. Because if there was some littlest difference like odor or anything, they're going to return that product and want their money back because it's not right. And that's why that was so important. Oh, let's have some fun with quaternary ammonium reactions. And the question is, what two starting materials would you react with base to make that molecule? And your turn. I'll be right back. All right, looks like everybody's done. In case you haven't realized it, you're doing some very sophisticated organic chemistry. All right, let's take a look at this. What's different here? Oops, that's not what I wanted. Hold on. Get rid of that. What's different there? Ooh, nitrogen. And notice it has two. Oh, I made a mistake. That should be a two there. Sorry. Dr. White does make mistakes once in a while. Two, that's four groups. And that's a quaternary ammonium salt. I hope you all picked that up. Somebody should have asked me. There's something wrong there. And how do you make a quaternary ammonium salt? Tertiary amine plus an alkyl halide. And here X can be chlorine, which mostly is for fabric softeners, bromine, or iodine. And I can say these two methyl groups are R and R prime, and one of these ethyl groups is R double prime, and the, let's see, this should be a single, and also R triple prime. In that case, two of the methyl groups are nitrogen, which I can write like this. There are other ways I could write it. And then Our double prime is an ethyl, and our triple prime is an ethyl. And what's the halogen? Chlorine. But I could also have said these two ethyl groups are R prime and R, and one of these methyl groups is our double prime, and the other is our triple prime. In that case, what you would start with and what's the R triple prime? Well, in this case, it would be a methyl group, and the halogen is still chlorine. Which one is correct? Both are, because both would give you that product. And that's how you make quaternary ammonium salts. And for many, many years, and still is, an important part of my life, besides teaching. So remember, next time you pick up a box or a bottle of fabric softener, you now know that has a quaternary ammonium salt. And the next time you pick up mouthwash, that Scope or the Walmart equivalent, that has a quaternary ammonium salt. Or think about it, the next time, did I talk about this? Yes, I did. Next time you go to a supermarket, or if you have them at home and use those wipes that are antimicrobial, that's a quaternary ammonium salt. By the way, I should point out that the type of quaternary ammonium salt on those wipes, oops, wrong color. Right color. For those antimicrobial wipes that are good for cleaning up surfaces, especially when we're dealing with COVID-19, this R group is either 8 carbons or 10 carbons, or a mixture of 8 and 10. And I worked for a company that made that. Before the wipes came out, a heavy use of that was for cleaning operating rooms in hospitals before an operation. Boy, you're learning some good stuff. All right, let's continue on. Now, there's a functional group that I'll just talk about, but I won't talk about the nomenclature or anything. You can have a carbon triple bonded to nitrogen, and this is called the nitrile. And nitrile has 2 pi bonds and 1 sigma bond. And what I forgot to write here, because I'm a lazy organic chemist, but for this class, excess hydrogen and a catalyst, you break the 2 pi bonds, and each atom of the triple bond gets 2 hydrogens. And this is a great way of making primary amines. And when I was at Axel, we did this reaction to the tune of about 2 to 3 million pounds a week, sometimes more, taking a nitrile and react with hydrogen and catalyst. Again, this is a nitrile. I'll never ask you what functional group is it or the nomenclature, which I know, but I won't talk about it here. But I'll use the terminology, so I better. And then if you take hydrogen, and because they're 2 pi bonds, we use excess for this class. Organic chemists don't even. And you have a catalyst. And if you forgot, that can be nickel, platinum, or palladium. And you break the 2 pi bonds. Remember, there's 2 pi bonds and 1 sigma bond, single bond. And each atom of the triple bond, nitrile, gets 2 hydrogens, which I can write it this way, or I can write it this way. And you make a primary amine. And let's look at the following reaction. What would be the organic product or products for the following? So you look for what's different, what's not carbon, what's not hydrogen, what's not a carbon-carbon single bond, or just a carbon-nitrogen single, or just nitrogen will give us away the triple bond, and we have a nitrile. And we're reacting with hydrogen. Nickel is a catalyst, hydrogenation catalyst. And what happens? You break the 2 pi bonds, and each atom of the triple bond gets 2 hydrogens. And you could also write it like this. So what's our R group? 2 carbons. And it's bond to this carbon, which is bond to nitrogen. Each one gets 2 hydrogens. I know there are 4, yes, 4. Let me fix my finger. 4 bonds to carbon, so I can put in my rest of my hydrogens, and you could have also written it like this. Either way, it's N-propylamine. Oh, let's see what I like you to do. Oh, I forgot to put the excess here. No, I didn't. All right, your turn. Give the organic product or products for the following reaction. 3 points each. All right, I think everybody's done. So let's get to work. Now, if we look at this starting material, what's different? What's not carbon? Ooh, a nitrogen triple bond to carbon. And it's a nitrile, which I'll never ask you. And we're reacting with excess hydrogen. That means you have all the hydrogen in the world that can react with anything hydrogen can react with. And nickel is a catalyst. And remember, the catalyst can be nickel, platinum, or palladium. And what happens? You break the 2 pi bonds of the triple bond, not the sigma, and each atom gets two hydrogens of the triple bond that you broke. And you could also write it this way. And what's my R group? Right here. These 4 carbons. Another way of thinking is, do you break carbon-carbon single bonds? No. So I have my 4 carbons. Here's the carbon, bonds to nitrogen. And you break the 2 pi bonds, which I did, and each one gets two hydrogens. And I put in the rest because I know there are 4 bonds to carbon. And I could have also written it this way. There's my R group. Then this carbon I can write as CH2. And the nitrogen I can write as NH2. Now, this reaction has very special place in my heart. When I started in the chemical industry, this was the first reaction I did my research on as a process development chemist working in a research group. And my job was to come up with a better process to make this, do this reaction. One of the problems is when I worked at AXO was the R group here that they normally made was very long, 12 to, or actually 10 to up to 20 carbons. But here the R group was only 4. And this reaction gives off heat that's called exothermic or an exotherm. And because of the way the plant and the reactors and the cooling pipes in the reactors were designed, they really weren't set up for the exotherm of the smaller molecule. My job was to find a way to do it in plant, and I did. But it was interesting, having come from academics, when I talked to my boss, I was talking to him, I said, I'll use platinum or palladium catalyst, because that's what I'd used in grad school for hydrogenations. He looked at me and started laughing. He said, have you looked up the price differential between nickel, platinum, and palladium? I said, no. You better find out and come back and talk to me about that. You already knew the answer. Platinum and palladium, because you don't recover all of it in a chemical plant, is just too expensive. And I learned about nickel real quick. And I solved the problem, but actually I came up with a new reaction to make, and we called these short chain amines, which helped me get, when my boss left, be the youngest section head at that company. Oh, let's do another one. What would you react with hydrogen in a catalyst, excess hydrogen, to make that molecule? Again, this is the fun part of organic chemistry synthesis, because this is what we use, the thought process, how to make molecules, new ones. or whatever we need to make. Ooh, I forgot to tell you something. I'll do it right after we do this reaction. And it's time to vote. And everybody's done, so I better get to work. If we look at this, what's different in the product? Ooh, nitrogen. Remember, what's not carbon, what's not hydrogen. And this is a primary amine. And what do you react with hydrogen and a catalyst to make a primary amine? And the answer is a nitrile. And this carbon here attached to the nitrogen of the amine is this carbon here, which means this carbon, and therefore this is our R group. So I'm going to, you don't break carbon-carbon single bonds, so we start with that. I have this carbon, it's triple bond to nitrogen. I know there are 4 bonds to carbon. And there you go. Now, what I just thought about, and I didn't talk about, and bad Dr. White, how many of you have ever heard of vitamins? I think most of you probably have. You know, vitamins is a shortened condensation of 2 words, and those 2 words are vital amines. And long ago, before they had all the sophisticated electronic equipment for identifying molecules, chemists or scientists in general thought there were these special molecules that helped keep us alive. They were vital. And somehow someone decided all of them have amines, so they were vital amines. And someone said, oh, let's shorten it. And it got shortened to vitamins. And that's how vitamins got their name. Now, it turns out not all vitamins have amines in them, but they're still called vitamins. How about that? Oh no, time flies when you're having fun with nitrogen compounds in organic chemistry. It's time for a break. Let's take a 5-minute break. I'll see you at 2:50. I'll be right back. You too. Time to get going. All right, everybody back? Are you out there? All right. Now, something very special about amines. Amines are bases. Now, let me remind you, what is a base? I'll never ask this on a test, but still it's good review. A base is a proton acceptor. So if you have an acid, HA, plus a base, B, aren't we clever? You have an acid-base reaction. The proton goes over here. And what this is really is a salt. And this is a straight acid-base reaction. Well, why am I telling you this? Well, because amines can be bases. Now, a very strong base is ammonia. And it accepts a proton from water to form this cation plus the hydroxide anion. This I'll never ask on a test. However, if you replace one or more of that hydrogens on ammonia with our groups, you have an amine. Now, don't write this down. Now, you have an amine reacting with an acid to form, this is called an amine salt. Now, there's a better way for me to show this, and this happens with all amines except quaternary ammonium salts, because what's attracting a proton? The non-bonding pair of electrons, which quaternary ammonium salts don't have. Now, better way to remember this reaction. And I'll just stick the HX acid. Remember, all molecules have a net zero charge, so that's why we have the anion here. And for this one, R prime and R double prime can be hydrogen. And so that covers if they're both hydrogens, a primary amine. If one is secondary amine, if none are, tertiary amine. So let's take a look at this. And here, if you have, what is this? Oh, it's a primary amine, but it could have been a secondary amine. Here, our prime and our double prime are hydrogen. This is my R group. Oh, HX. Remember, X can be chlorine. In this case, it's bromine or iodine. And this is a straightforward acid-base reaction, proton transfer, and you made an amine salt. And in this case, what's our ethyl? Our prime and our double prime are hydrogen. Notice you add one more hydrogen, and we can write it this way. 2 plus 1 is 3. You don't have to show charges, I will, the anion. You could have also written it this way. And this is an amine salt. And that's how you do it. Now I'll explain why amine salts are important in our daily life. And here's one for you to have fun with. But I think we are where I think we are, where we'll be at Wednesday in this chapter. I will have a very important announcement to make to all of you. So be sure to pay attention on Wednesday for that very special announcement. I think everybody is, I'll give you another 3.8 seconds. 1, 2, 2.6, 2.75. All right, everybody's done. Let's do this. What do we see that's different? Ooh, a nitrogen. And what do we have? Carbons here and here and a hydrogen. And this is a secondary amine. But since we're reacting with an acid, HX, I'll write it like this. And here, X can be chlorine, which it is, bromine, or iodine. And this is a base. This is an acid. And you get an acid-base reaction, and you form an amine salt. Again, you don't have to show charges, but I will. So I can call one of these R, doesn't matter which you call. I can call this R prime, and this hydrogen R double prime, because in this reaction, R prime and R double prime can be hydrogen. Bad, Dr. White, I should have written it here too. Be sure to change your notes or go back and look at the video. So what's attached to nitrogen are R prime will still be there to methyl. And notice you add one more hydrogen. Well, we had one to begin with. I'll add one more. 1 plus 1 is 2. This has a positive charge. What's my anion? X is Cl. So that would be Cl minus. You do not have to put charges, but I will. And that's how you do it. Oh, let's try one more. And HBr will not react with a benzene ring under these conditions, under almost any conditions. All right, I better get to work. We look here, oh, we got a benzene ring. That's a functional group, but it will not react with HBr. But I've got a nitrogen here, and it's got two methyls and a benzene ring. That's a tertiary amine. But it could have been a primary or secondary, because R prime and R double prime can be I'm not going to hydrogen. And this is HBr, which is HX, an acid. And for this class, X is chlorine, bromine, or iodine. Now, it could be other acids, but I'm just, for this class, going to stick to this. And you make an amine salt. Well, I can call one of these R, and these two are prime and are double prime, and therefore they'll still be attached to nitrogen. Don't forget to put the lines in the benzene ring, otherwise it's cyclohexane. I still have my two methyl groups on there, but now I'll add this hydrogen. You don't have to put the charge down, I will. And my anion is bromine, and that's how you do it. Now, I'll teach more about this later when we get into surfactants, but when you have an ionic compound, a salt like this, it makes it more water soluble. And where's something that you like more water soluble? Well, a lot of the medicine you take. If you look at different prescription drugs and over-the-counter drugs, you'll see the names of amine salts. And a lot of the active ingredients in over-the-counter and also prescription medication, the molecules have amine salts that help make them more water soluble. Where? In your blood or in your stomach. All right, now I haven't talked about it, but let's talk about nomenclature. And one of these decades, I'll make up a slide for this, but not today. And this is real hard. And it's the same as quaternary ammonium salts. And what is that? For the common names, which we'll use in this class, all right, so how do you name amine salts? Same as quaternary ammonium salts. Name each R group as the alkyl group it is in the front, and then add the words ammonium halide at the end. And remember, this is chloride. This is bromide. And this is iodide. And that's how you name it. Now, a common question students ask me is, well, if you name them the same as quaternary ammonium salts, how do you know the difference? Well, you know the difference because a quaternary ammonium salt always has 4 alkyl groups. That's why it's got the name quaternary from 4. Amine salts never have 4 alkyl groups. They can have up to 3, but they always have at least 1 hydrogen on the nitrogen. I lost count. Sorry. And the question is, what's the name of this compound? And notice it's an amine salt. Remember, amine salts are the form like this. Where R prime can be hydrogens or they can be alkyl groups. So how do you name this? Well, I've got 2 methyls and an ethyl. And since this is a common name, you can make it any order. 2 methyls is dimethyl. 1 ethyl group, ethyl, ammonium. and bromine is bromide. Again, name each alkyl group and put that in front on the nitrogen, then add the words ammonium. Let me clean this ammonium up. And the halide is bromine, which is bromide. And there's your turn to have fun. What would be the name of that molecule? The
Could
comment.
you scroll up for a second, Dr. White?
I can scroll up for 2 seconds.
Yeah, thank you.
All right. And remember, oh, I haven't said this in a long time. Remember, there's no such thing as a dumb question in my class. Remember, Dr. White's got the fastest mouse wheel finger this side and the other side of the Mississippi. I could say the Atlantic Ocean too, but I like the Mississippi better. All right, give the common name for this compound. Now we'll get this near the end of the semester. An important nitrogen compound that forms amine salts in your stomach are amino acids, which have an amino group in them, an amine. And that helps make those amino acids and also proteins more water soluble in your stomach and in your blood. So are amine salts important? Of course. All right, let's do it. What's different? Ooh, got a nitrogen. It's got a plus charge anion, and it's got 1 R group and 3 nitrogens. Now, 2 of those nitrogens could be R prime and R double prime. Oops. Wow. I'm out of practice. See what happens when you're a week away from your tablet? There we go. And this is an amine salt. Remember, R prime and R double prime can be hydrogen. In this case, they are. So how do you name that? Name the alkyl group. What's this? Ethyl. And then that's the only alkyl group. And what's the halide? Chloride. If I can spell. Oh no, my brain's stopping. There we go. Oh, we've got to do another one. And there you go. there's another one for you to have fun with. Give the common name. Now in test 3, I'm going to have to redo the nomenclature. Where normally I say give the IUPAC, now I'll say give the IUPAC or the common name, because the nitrogen derivatives or nitrogen compounds, I really am not asking you to learn the IUPAC. Nobody uses them. Except in contracts and patents, legal documents. Even then, sometimes they don't even use them. All right. Let's take a look at this. And how do you name this compound? Well, I've got a positive charge, and I've got 3 alkyl groups on nitrogen and a hydrogen. And this is an amine salt. Now, how do we name it? Name the alkyl groups. Well, I've got 2 methyls and 2 is di. And since this is a common name, there's no rules which go first. And then over here, I have an ethyl. And then I'll add, I'm running out of room, so I'll put it under here. Ammonium. And what's the anion? Bromine. And that's how you name and react amine salts. Like I said, this is a great compound. Certain amines are used because they can make the amine salts to adjust the pH in things like hair conditioners, shampoos, and makeup. So if you're wondering, why am I learning this stuff? Well, if you use conditioners, shampoo, well, I forgot to put on my makeup today, don't tell anybody, or makeup, these are molecules that can be used in there. Uh-oh. It's new functional group time. And we get to talk about a new functional group. Now, this new functional group can be very hot and dangerous too. And it's important. We'll learn how important part of who we are, like our skin, our hair, what's left of it, or my beard, what's still not gray. Oh no. But anyways, what's this new functional group? And this new functional group is called the amide. And why isn't this centered? Hold on one second. Now it looks better. And an amide is a carboxylic derivative. And a carboxylic acid derivative is something made from a carboxylic acid, which the hydroxyl group is replaced by an amino or substituted amino group. And here we have an amide, and this way my software drew it. Let me rewrite it. Have a carbonyl, carbon double bond oxygen with an R group on it. And attached to that carbonyl is a nitrogen. And on that nitrogen, we have 2 groups, R and R prime. And this is an amide. And I should point out R and R prime and R double prime can be hydrogen. Now, I'm not going to go through the nomenclature of amides. For the most part, you're not going to encounter it in your daily life, even though I do know it, and there are also common names for amides. But this is an amide. Now, the switch is totally off for this slide, but once in a while I'll use the terminology. This is a primary amide, and this will never be on a test. Secondary amide. Ooh, see board. All you have to do is look above. Right now, if we were in a classroom, you'd see me writing this on, and that's the tertiary amide. And these are amides. They play an important role in our life. Oh, you say that about every compound. Well, they do. Now, switch is still off. You can have. I'm popular today. I have no idea. Let me turn off my mic so you don't have to listen. That should be it. Why? I didn't win the lotto. I wonder why everybody's calling me. But anyways, this is a cyclic amide. And notice you have here carbonyl, nitrogen, carbons here, and this is called lactam. It will not be on test. And here are R prime, just like in cyclic ketones or other compounds are connected together. That's called lactam. All right, this switch I'm going to turn on because it's an important compound. This is called urea. Now, at first glance, you look at that, and I can write it like this. And here, the R group is NH2, and R prime and R double prime in an amide are hydrogen. Now, urea undergoes many of the reactions amides in general do, so that's why it's called an amide. And the interesting thing about urea is it's the major organic chemical in urine, whether human or animal. And this is one way our body gets rid of nitrogen waste. Now, one of my more interesting memories was, and we'll talk later on when we get into polymers, urea is a white solid. In your urine, it's soluble in the water in your urine, so that's why you don't see a white solid, but it's a white powder or solid. And it can be used for many things to make polymers, which I'll talk about later on. And polymers, the one company I worked for used urea, and I was supervising a reaction of mine, new one in the plant, and they had what's called super sacks. And these are these huge bags. They have about 2,000 pounds of chemical in there. And it's usually, it should be a powder. And I had been in that plant before, and the urea was always a powder. Well, we go to use the urea, which is an amide, and we open up the super sac and look in there, and it's like a solid rock. Well, guess what? I and about 5 other people spent the next hour doing, taking turns with sledgehammers, 10 or 20 pounder, to break it back up into powder. I got a good workout that morning. Wow. You never know what to expect in a chemical plant. Now, this is urea, and you should know this is the structure. And like I have here, urea formaldehyde polymers are important use of urea. Also for, I think, fertilizer too, but don't quote me on that. Now, time to talk about why are we learning about amides? And the first thing is, I'm going to talk about one of the more dumber things I've done in my life. Yes, I've done some dumb things. This one was pretty dumb, but luckily I'm an organic chemist. How many of you ever had peppers? And you know, there are different ones that are hot, hotter, and really hot. What makes a pepper hot? Well, it turns out there's an amide in there. And the amount of this amide, the more there is, the hotter it is, the pepper. I like hot food, but not where I'm going to be in pain. And you don't have to write this down, but I thought I'd teach you this. The chemical that gives heat to peppers has a common name, capsaicin. And you've got a couple of functional groups in this molecule. You have an ether here, an alcohol, you have a benzene ring, double bond, and here you have an amide. This is a carbon, each bend of the line is a carbon. And this is capsaicin. And the more that's in the pepper, the hotter it is. Well, let's see if I can find it real quick. There's a great place in Chicago and Evanston. They used to have one out in the northern suburbs, and they sold that store for whatever reason. All right, everybody see on the screen ground habanero chilies powder? Well, they just, a number of years ago, they sold this for the first time. And I bought a bottle like this and it looks pretty innocent. So I got home and it's this kind of powder, open the top, and there's just a little between the white, the perforated things on bottles and the cap. I wonder, how hot is this stuff? Boy, what stupidity. So I went like this, put it on my tongue, and immediately I was in instant pain. I mean pain. My tongue, the inside of my lips, my mouth, my gums. Oh, was I in pain? I mean, to the point where I better get to the hospital. It was that bad. And then luckily, and I'll teach this later on the semester, there's something, a rule of thumb. It's on this thumb, see it? A rule of thumb means it's true 95% of the time, called like dissolves like. Things that are polar are soluble in polar things. Things that are nonpolar are soluble in non-polar things. You mix two together, nonpolar are not soluble in polar, and vice versa. Water is the most polar substance in the universe, in our world. And drinking water isn't going to get that pain out of your capsaicin out of your mouth, because capsaicin is non-polar. What else is non-polar? Butter is, vegetable oil is, and I happen to be standing in my kitchen right next to my refrigerator when I did this stupidity. And underneath the countertop was also where I keep the drawer of my silverware. And I'll teach you later in the semester when we get into the proper chapter that mayonnaise is made up of 50% water, but 50% oil, a fat. And I'll teach you about this later on. So immediately I whipped open the refrigerator, took out a jar of mayonnaise, got a spoon, went over to my sink, put some in my mouth, switched it around, my mouthwash, did it into the sink, did it a second time, and it was gone. Luckily, I'm an organic. Otherwise, I mean, I was in serious pain. Now, when I use that stuff, I'm very careful how much I put in there. Like if you have a big pot of chili, you just don't go like this because you'll be on fire. I mean, literally. But it tastes so good. It gives that right amount of heat. And if you've ever been at a restaurant or someone where somebody is eating something, a hot chili pepper, or in Chinese restaurants, they'll usually bring them some milk. Why milk? Well, there's fat in milk. Now, how many of you ever had buffalo wings? And you know how they bring out the celery there with the blue cheese dressing, I think it is. I don't like blue cheese, but anyways, why are they doing that? Because if you get, which I don't, the super, super hot, now your mouth is, guess what? By eating some of that dressing with the fat or non-polar material in there, it gets the capsaicin out of your mouth. And I'll really go through the story again, but I learned my lesson. When they say hot, don't taste it like that. There's safer ways of doing it. And if we go back here, they have a lot of different chilies. And I saw when I was looking, there's a ground habanero. This ground chipotle is not as hot and it's awesome. Their cayenne is really good. And those are all products that have capsaicin. Their sweet paprika is good. There was another, they had another new, I can't find it now. Some very hot new peppers that are crushed that are even hotter than habanero, which is dangerous. So this is capsaicin. Now, there's another place where you can use or find amides, and that's in, have you ever gone to a supermarket in the produce section and they have where you can pull the bags off the roll nowadays and pick your own produce and put it in there? If you ever pull the bag off the roll, and in the last couple of years, they even nice enough to put a arrow, say, open this end, and you go, and the darn bag won't open up. It just won't open up. Well, it turns out plastic, because of what's called van der Waals forces, likes to stick together. And there's an additive called the slip reagent. And that makes the plastic slip apart so you can open it up, like in a bag. Well, what's the slip reagent? Well, it just so happens I work for this company, Axo, and it's an amide. And this R group in the amide is about 20 carbons to 22 carbons long. Actually, this would be 19 to 21. So this whole thing is an even number. And the long R group makes it slippery, just like wax is slippery. And what I do, if I'm ever in a supermarket and I grab a roll, a bag off a roll, after about 5 times I can't open it, I'll say, the company who made that bags through when they made those were cheap. They didn't put enough slip reagent in there. And I go and find another roll, and hopefully that one they put more in, and usually it's the case. So I bet you never thought you learn about bags you can get in the produce department of a supermarket from Dr. White. Now, how do you make amides? Now let's skip this slide right here because I'm going to do a different one like here, and I'm going to show you on my whiteboard how to help you remember this in general. to make an amide, you react the carboxylic acid with this. Now, R prime and R double prime can be hydrogen, or they can't. If they're both hydrogen, then this is ammonia, NH3. If not, it can be a primary, secondary amine. And you make an amide. Now, an amide, just like in amines, nitrogen has only 3 bonds to it. Again, in an amide, the nitrogen has 3 bonds. The only time it has 4 is in a quaternary ammonium salt. And if we look at the following, what would be the organic product or products for the following reaction? Now, one other thing you get here, which I don't talk about because it's inorganic, you get water also. So what do we have here? Ooh, carbonyl with hydroxy group of carbon, a carboxylic acid. Here we have nitrogen with 3 hydrogens, but I can write it like this, and R prime and R double prime can be, in this case they are, hydrogen. And what you get is an amide. So what's our methyl? What's R prime and R double prime? Hydrogen. And then you get this molecule. Now, excuse me for a second, I gotta go blow my nose.
Dr. White, you're still muted.
Oh, I said, that's how you make an amide. Thank you. I was saying yesterday, I think I was fighting off a cold or something because yesterday I was a little under the weather. Today I feel much better, but my nose needed attention. And speaking about attention, oh no, we're done for today. Time flies when you're having fun with nitrogen derivatives. And with that, don't forget, hand in your lab. I'll be grading a lab. I got to do the tomorrow. I sort of last week got busy with other stuff, right? But anyways, I'll get on that. And don't forget to hand your lab on before Wednesday that we did before the break. And don't forget, I will have my office hour tonight. With that, I'll say, gang gesund, be healthy, bye.